All right, so today we're going to start chapter 2, talking about graphs and functions. All right, so the first thing we remind ourselves of, review, is the distance formula. As a reminder, the distance formula is D, which represents our distance, is equal to the square root of x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1. And that quantity is also squared. The first type of example we're going to see here is just us plainly trying to figure out what the distance between 2 points is. So if we're given the point P, which is the order pair 3, -5, and the point Q, which is the order pair -2, 8. We're trying to find the distance between those 2 points. So this is a good candidate for a distance formula problem. First thing I would suggest is to go through and label your points. The distance formula, like the midpoint and slope formula, are pretty straightforward. The most common mistake is people mislabeling their points. So this is the way I always label them. I just go X, Y, X, Y, my first X, my first Y, second X, my second Y. Now I'm just going to plug everything into its appropriate place in the distance formula. There is x2 minus x1, or in this case, 8. Oh, I'm sorry. It's -2 minus 3. That quantity squared, that's my x2 and my x1 respectively. Plus y sub 2 minus y sub 1, or in this case, 8 minus a -5. And that quantity is also squared. Okay. Want to remember that anytime we subtract negative, same thing as addition. So here that 8 minus a -5, same as 8 plus 5. So we have -2 minus 3, or -5 quantity squared, plus 8 plus 5, which gives me 13 quantity squared. We know -5 squared gives me 25, plus 13 squared gives me 169. Or the distance between the points P and Q given to us in the problem is just simply the square root of 194. Next type of problem we're going to see in this section. Still dealing with the distance formula. This time we're asked to determine if M, N, and P are vertices of a right triangle. We're given the point M, which is the order pair 0, -2. N, which is the order pair 5, 1. And P, which is the order pair -4, 3. Now, determining something is the vertices of a right triangle, or the points given are vertices of a right triangle. You want to remember, we have a Pythagorean theorem for right triangles. This is a reminder. That's a squared plus b squared is equal to c squared. So if we find the distance between m and n and p, and lastly m and p, keeping in mind that the longest leg of a right triangle is the hypotenuse. That's where the c goes in the Pythagorean theorem. And if it gives us a true statement, we know that these are vertices of a right triangle, where if we plug everything into its appropriate place and get a false statement, then we know that these vertices, namely m, n, and p, are not vertices of a right triangle. So the first distance that we want to find is the distance from m to n. All right. So the distance from m to n, which would be the square root of x2 minus x1, or in this case, 5 minus 0, quantity squared, plus y2 minus y1, or in this case, 1 minus a negative 2. We know if we subtract the negative, same thing as addition, so we can just put 1 plus 2, quantity squared. So this is really the square root of 5 squared plus 3 squared. We know 5 squared, 25. 3 squared is 9. So we're really looking for the square root, or the distance between m and n will be the square root of 34, which is 25 plus 9. Next thing we need to find is the distance between n and p. So we're going to take our x coordinates, or in this case, -4 and +5, subtract them. So we're going to have -4 minus 5 quantity squared plus our y's, 3 and 1. So in this case, it'll be 3 minus 1 quantity squared. -4 minus 5, same sign. So we subtract, or excuse me, add and keep that sign. So this will give me a -9 squared plus 3 minus 1 will give me 2. So we'll be adding 2 squared to that. We'll end up with the square root of -9 squared, which is 81, plus 2 squared, which is 4. We end up with the square root of 85 for the distance between n and p. And lastly, what we need to find is the distance between m and p. So we're using the points 0, -2, and -4, 3. So we're going to take our y coordinate, excuse me, our x coordinates and subtract them. So in this case, it would be -4 minus 0 quantity squared plus 3 minus a -2, or 3 plus 2 quantity squared. We know -4 minus 0, this is going to give me -4 squared, plus 3 plus 2 will give me 5. So we'll be adding 5 squared to that. All this is obviously our radical. So that's going to give me the square root of 4 squared, which we know is 16, plus 5 squared, which we know is 25. Or the distance between m and p will be the square root of 41. All right, now that's a lot of mundane work in this problem. So it's really easy to forget what it is we're doing. Remember, these are the vertices of we're trying to see if these vertices are the vertices of a right triangle. Once we get the distance between MN, NP, and MP respectively, this gives us a size to our triangle. Remember, if it's a right triangle, I mean the Pythagorean theorem holds. Keeping in mind the longest side, or in this case, the square root of 85, is our hypotenuse. So this means that the square root of 34 and the square root of 41 are the sides, are our legs for the right triangle. Or at least if it is a right triangle, these will be our legs. So we're going to have a squared, or the square root of 34 squared, plus the square root of 41 squared should be equal to the square root of 85 squared. Keeping in mind that the square root of 85 is the longest distance of the three sides for this triangle. And we're trying to see if it's a right triangle. If it is, then this will give us a true statement. So we know the square root of 34 squared, the square root and something squared is going to cancel out. So it's going to leave me with 34 plus square root of 41 squared, square root and squared is going to cancel out again. So we're left with 41 equals the square root of 85 squared, which leaves me with 85. Now 34 plus 41 is going to give me 75. And we know 75 does not equal 85. So this is a false statement, which in turn lets me know that this is not, the vertices M, N, and P are not that of a right triangle. So we do want to take note that if the statement is true, then we know it's a right triangle. And in this case, if it's not, then it is not a right triangle. All right, so do keep in mind that if it's a right triangle, the Pythagorean theorem holds. All right. Any questions on this example? Next thing we need to review is the midpoint formula. Remember, the midpoint is basically halfway between two separate points, but the formula for the midpoint formula is going to be x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. We're basically taking the average of the x coordinate between the 2 points and the average of the y coordinates between the 2 points. So an example of the midpoint formula, if we're given the point P, which is the order pair -7, -5, and Q, which is the order pair -2 and 13. And we're asked to find the midpoint between these two. Like I've said before, if it's the most common mistake that I see with problems like these, this is true for distance, midpoint, and as well as the slope formula, mislabeling our points. So once again, that's x, y. Our x comes first, y comes second in every order pair. My first x, my first y, second x, second y. It's a very small step, but I can tell you now that's it pretty much eliminates the most common mistake when I see these problems. All right, so plugging everything into its appropriate place into the midpoint formula. It's going to bring this down here. So we have x1 plus x2, or in this case, -7 plus a -2. This is all being divided by 2. That's the first coordinate in my midpoint. And y sub 1 plus y sub 2, or in this case, -5 plus 13. All of this is still being divided by 2. So remember that the midpoint is an ordered pair, so we should have two numbers. Here we have -7 plus -2. Signs are the same, so we're basically adding and keeping that sign. So we end up with -9 over 2, or -9 halves. That's the x coordinate. And for -5 plus 13, signs are different, so we're really subtracting, taking the sign of a bigger number. 13 minus 5 leaves me with 8. 8 divided by 2 leaves me with 4. So the midpoint between the points -7, -5, and -2, 13 will be the ordered pair of -9/2 and 4. Another type of problem we can see is technically a midpoint formula problem. Here we're asked to find the endpoint which is Q, given that P is the ordered pair 8, -20, and our midpoint M is the ordered pair 4, -4. All right, so seeing that we're looking for this endpoint Q, which is the ordered pairs that we're looking for, so we need the X coordinate and the Y coordinate, we can use the midpoint formula, at least the understanding of it, which is the sum of the X coordinates, the sum of the Y coordinates, and they're both being divided by 2. For our X coordinates, we know that 8 plus something is going to give us, 8 plus something divided by 2 is going to give us 4. So we're just going to write that out. That's our something, that X coordinate for the Q that we're looking for, plus the X coordinate of P has all been divided by 2. That's going to give me my midpoint X coordinate of +4. We can do the same thing for the Y coordinates. So we know there's some Y plus -20 divided by 2 is going to give me the Y coordinate of my midpoint, which we know is -4. All right. So now all we have to do is solve these two equations independently. Here, X plus 8 divided by 2, if it were me, first thing I want to do, get rid of my denominator by multiplying both sides by 2. So now I'm just left with X plus 8, which is what I'm left with. The 2's cancel out. Is equal to 4 times 2, which is also 8. Get the X by itself. We end up with the X coordinate for that point Q that we're looking for. It's going to be 0. And I'm just going to solve this part for the Y coordinate. Now, Y plus a -20, or another way of saying this is Y minus 20 over 2 is equal to -4. Just like before, first thing I want to do is get rid of my fraction, multiply both sides by the denominator 2. That is equal to Y minus 20 on the left-hand side is equal to -4 times 2, or -8. And then get the Y by itself. It's going to add 20. Sorry about that. Now, Y minus 20 is equal to -8. It's going to add 20 to both sides. And 20 minus 8, or -8 plus 20, with a +12. So as far as that ordered pair, which represents the point Q, is going to be the ordered pair 0, +12. Right. Any questions on this example? All right, next type of problem we're going to deal with ordered pair solutions to the equation. This time we're basically going to be graphing an equation by picking some points or some values for X. Technically, we can use any points we like for X. The ones I typically lean on, -1, 0, and +1. This way I can see what happens on each side of the Y-axis, as well as what happens once it goes right through the Y-axis. Once again, that's the ordered pair solutions for the equation. Technically, we only need 2 points to define a line. I like to lean on 3. All right, the more points we have, the more accurate our line. Technically, we can pick any numbers that we want. You're going to see me use X values of -1, 0, and 1 most often. All right, so if we're given the equation, y is equal to -2x plus 5. And we want to graph this equation by plotting points. We want to pick some X values. Remember, technically, we can use any X values we want. The ones I typically lean on, -1, 0, and 1. We're going to run them through the given equation to see the y coordinates that are associated with it. Yep. So for the first point, we're going to replace every X in the equation given with a -1. So in this case, it would be a -2 times -1 plus 5. Or we end up with a +7. We do the same thing for 0 and +1. So we have y is equal to -2 times 0 plus 5, or the y coordinate associated with the x of 0 is +5. And lastly, we have y is equal to -2 times +1 plus 5, or the y coordinate associated with +1, given that we have the equation -2x plus 5 and +3. So the ordered pairs that we're going to have to plot is the ordered pairs -1, 7, 0, 5, and 1, 3. Now keep in mind the homework, it is going to be on the computer. So you have to, you may have to play with it a little bit. By it, I mean the computer to get your points right. But provided that we do everything correctly, this should form a straight line. And if it doesn't form a straight line, we messed up on our algebra somewhere or our operations. So we can go to -1, 7. To the left 1, up 7. 0, 5. And then the order pair 1, 3. So to the right 1, up 3. And once we connect those dots, I'll connect our points, it should form a straight line, which is the graph of the equation y is equal to -2x plus 5. Okay. Any questions on that first example? More of the same. This time we're given the quadratic or the equation y is equal to -x squared plus 1. I'm gonna pick some X values. Remember the ones I typically lean on, -1, 0, and 1. Run them through our equation to see the associated Y values with the particular X's that we've chosen. So for X is equal to -1, we will have a -1 squared plus 1. Or we end up with 0 when we plug in -1 in for every X in the given equation. Second, we'll end up with -0 squared plus 1. Or we end up with +1. And for the third, we'll replace every X in the equation with +1. And it will be -1 squared plus 1. And we end up with 0 again. So those are the pairs that we're going to be graphing here. -1, 0. 0, 1. And 1, 0. All right, so our first point, -1, 0, it's going to go to the left 1. And that point is going to be right on the x-axis. 0, 1, go to the left or right, none, up 1. It's another point on the y-axis. And 1, 0, going to the right 1, up or down, none. And we connect these dots. It's going to graph a parabola. It's facing down. And keep in mind, we do have a graphic calculator, so it's always very easy to check and see if these are correct. We just simply graph this function. Now remember, this is a quadratic, so it should not be linear. I said all that to say that this will not be a straight line. All right, so next thing we're going to need to do in this section or review is graphing by plotting points. First thing we want to do is find our intercepts. So remember, when we're dealing with our intercepts, in particular our x-intercept implies that y is equal to 0 and vice versa. For our y-intercept, this implies that my x is equal to 0. Second step, remember this is going to give me 2 points. I like to graph 3. This is going to make the graph accurate. So second step, we want to find an additional ordered pair. Remember, we can do this by simply picking any x value that we want. If it were me, I'd probably pick 1 or some number in between these x-intercepts, just so I can see the behavior of the line. And then last step, plot and join points. All right. So you just want to remember that when we're dealing with the x-intercept, that means we can substitute 0 in for y. And if we're dealing with a y-intercept, we can substitute 0 in for x. Now, so our first example. We're given the equation y is equal to 4x minus 1. We're going to graph by plotting points. First thing we need to do is find the x-intercept, the y-intercept, and then we can find an additional point of our own choosing, just to be sure that everything lines up the way it should be. So first things first, my x-intercept. Remember, x-intercept implies that my y is 0. So for this equation, we will have 0 is equal to 4x minus 1. We can solve this for x by adding 1 to both sides and dividing both sides by 4. And we'll end up with x is equal to a positive 1/4. So my x-intercept will be 1/4, comma 0. Next thing we're going to find is my y-intercept, which implies that my x is equal to 0. Or for this equation, we have we have y is equal to 4 times 0 minus 1. Just simply going in and replacing all the x's that I see with 0, or y is equal to -1. Will be my y-intercept, more specifically, my ordered pair. Will be the ordered pair 0 and -1. And lastly, for my additional point, I can just take my x to be equal to 1. which means that my equation would be y is equal to 4 times x, but like we said, x is 1 minus 1, or this will give me a y of 3. So the last order pair will be the order pair 1, comma 3. All right, so we have 3 points, 1, 4, 0, 0, negative 1, and 1, 3. This is good. This is enough for us to get a good sketch of our line. All right, so for our first point, 1/4, 0. We're going to go to the right, 1/4 of a unit. If this is 1 unit, it's halfway, a fourth will be about right here. So it's 1/4, 0. That's a point on my line. 0, negative 1. So we're going to go to the left or right, none, down 1 unit. It's another point on my line. And lastly, 1, 3. So we go to the right, 1, up 3. That's the last point on my line. Once we have 3 points, really we can define a line with 2 points, but once we have 3, we know that line is accurate. And that'll be the graph of the equation y, which is equal to 4x minus 1. All right, next example. This time we're given the equation y is equal to x squared minus 4. We're going to use the same techniques to graph this line, or graph this parabola. My x-intercept means y is equal to 0. Y-intercept means x is equal to 0. So for the x-intercept, we have 0 is equal to x squared minus 4. Or we end up with x is both positive and negative 2. Just by adding 4 to both sides, taking the square root. Remember that when we take the square root, we must account for both the positive and the negative answers. All right? So we have 2 x-intercepts. I have positive 2 and negative 2 on the x-axis. For my y-intercept, remember that means x is equal to 0. But we have y is equal to 0 squared minus 4. Or we end up with y is equal to negative 4 as my y-intercept. All right, so if we're sketching the graph, so we know we have 2 x-intercepts, one at positive 2 and one, and then again at negative 2. So at negative 2 is going to be a point on my graph. Go to the right 2 at positive 2, another point on my graph. These are my x-intercepts. And for my y-intercept, we know that's negative 4. So we just go straight down 4. Now, because we have 2 x-intercepts in this case, there's no need for an additional point. But if we combine those points, we'll see we have a parabola facing upward. It goes through the order pairs negative 2, 0, positive 2, 0, and 0, negative 4. Keep in mind, we do have graphic calculators. Good idea to check your graphic calculator. Use your graphic calculator to check the graph that you're plotting by hand. The last problem we're going to have in this section, we are going to go to 2.2 dealing with circles. An absolute value problem. We're graphing this by plotting points. And eventually we're going to go to transformations of functions. So if we're given the example, the absolute value, or excuse me, y is equal to the absolute value of x plus 1 . Remember, the x-intercept implies that y is equal to 0. That can be the first thing we solve for. So here we have 0 is equal to the absolute value of x plus 1. Remember that with the absolute value equations, we're supposed to account for the positive and the negative of the number that we have. Now, because it's 0, there is no such thing as -0. We can actually just solve this for x and drop off the absolute value bars. Or we have 0 is equal to x plus 1, or our x-intercept is -1, more specifically. It's the order pair -1, 0. All right, for the y-intercept, the y-intercept implies that x is equal to 0. So we have y is equal to the absolute value of 0 plus 1 on my y-intercept. We know 0 plus 1, 1, the absolute value of 1 is also 1. So my y-intercept is 1. More specifically, it's going to be the order pair 0, 1. Yeah. We can also go to an additional point because we only have 2 points here. So for our additional point, we can choose x to be equal to 1, which means that the y value associated with it will be y is equal to the absolute value of 1 plus 1, or we end up with 2. So our third point is the order pair 1, 2. Right, now we're sketching this graph. We know we have the order pair -1, 0. I will go to the left 1, up or down none. That's a point on my graph. We also have the order pair 0, 1. Left or right none, up 1, another point on my graph. And we also have the order pair 1, 2. To the right 1, up 2, another point on my graph. Now, for this particular example, because of the absolute value, and you'll see we get the transformation of functions, it actually will help us to get another point. So then we have, we know what happens at -1, 0, and 1. Let's see what happens at -2, or if x is equal to -2, and my equation is y is equal to the absolute value of -2 plus 1, or the absolute value of -1, which is also 1. So the ordered pair, -2, 1, also on my graph. So go to the left, 1, 2, or 1. And we can see that this point does not form a straight line, but this is because the shape of the absolute value graph actually looks like a V. So this will actually be the shape of this graph. All right, so keep in mind the absolute value graph should look like a V. And depending on how it's transformed, the tip of that V is going to be moved. Right. Any questions on this example? Every single time. Now, whether that V opens up, opens down, shifted left or right, that's going to change on the problem. But if you're doing it right, it should look like a V every single time. Next section that we need to go over, 2.2, dealing with circles. The technique we're going to use when trying to deal when graphing these circles or dealing with circles themselves is going to be completing the square. All right, so real quick, we need to go over the definition of a circle. So by definition, a circle is a set of all points in a plane that are a given distance from a point. And whenever we're talking about the equation of a circle has a certain form. So the equation of a circle is always of the form, well, of the two forms, depending on where it's centered. X squared plus y squared is equal to r squared. This is the equation of the circle when the center is at the origin, or the order pair 0, 0. And if it's not centered at the origin, then the form or the equation of the circle will be x minus h quantity squared plus y minus k quantity squared is equal to r squared. This is what r being the radius, x and y being the x and the y components for those points. All right. Now, what we typically refer to as these two equations is the center radius form for the equation of the circle. All right. So whenever we see the center radius form, this is what they're referring to. All right. So typically, whenever we're talking about the center of a circle, if it's centered at 0, 0, then it's just going to have x squared and y squared in it. Where if it's of the second form, then the center is the order pair h, k, or the opposite of what we see inside our factors. All right, so a quick example of the type of problem we're going to see. We're asked to find the center radius form of a circle whose center is at the order pair -3, 4, and whose radius is 6. You want to remember that the center radius form, and the circle whose center is not at the origin, x minus h quantity squared plus y minus k quantity squared is equal to r squared. And note that the center is at the order pair h, k. So it's going to be the opposite of what we see inside that formula. So we see -h. That's because the center is at h. We see -k. That's because the center, the y component of the center is at k. So here, when we see -3 for my x component, we're going to put x plus 3 for the center radius form, quantity squared, plus we see +4 for the order pair for our center. So we're going to write -4 in the center radius form. Right. So we have x plus 3 quantity squared is equal to, x plus 3 quantity squared plus y minus 4 quantity squared is equal to the radius squared. So if our radius is 6, the radius squared is 36. And this will be the center radius form for a circle whose center is at the order pair -3, 4, and whose radius is 6 units. All right. Any questions on that? Nah, not right here. This is the simplest question, but later on, we're going to have to complete the square to get that form. All right. Same type of problem this time. We have the center at the order pair 1, -2. And the radius is 3 this time. So no matter what circle we're dealing with, we're going to have some x component squared plus some y component squared is equal to the radius squared. In this case, we see +1 for our x component. So we're going to have a -1 in the factor. So we have x minus 1 quantity squared. We see -2 for the y component. So we're going to have y plus 2 quantity squared for the y component in the equation. And of course, my radius is 3. So 3 squared will give me 9. And this will be the center radius form of a circle whose center is at the order pair of 1, -2, and whose radius is 3. The last type, if we are given a circle whose center is at the order pair of 0, 0, and whose radius is 2, in the center radius form, x squared plus y squared is equal to 4. Remember, if we have the center of a circle at the origin or at the order pair 0, 0, then the left side of our equation is always going to be x squared plus y squared. And remember that this r squared is a part of our formula, so if they give us the radius, square it so that we can put it in our equation. So, next type of problem we have, you're going to see in this section, is if they give us the graph and we're asked to write the center radius form. All right, so if we're given the graph of a circle, and I'm drawing this by hand, so I apologize if it doesn't look too accurate. All right, so we're given a circle whose center is at the order pair 2, -1. We're going to the right 2, down 1. Also has a point at the order pair 2, 2. Also has a another order pair that goes to the order pair 4, -1. 2, -4. And then lastly, -1, -1. So it forms this circle. But what's most important is that from the graph, sorry about that, that's a very ugly circle. But we can see that the center of the circle, like I said, is at the order pair 2, -1. And the radius of the circle, which is a point from the center to any end point, is going to be 3 units long. All right, so once we have the center and the radius, that's enough for us to get the center radius form of the equation of the circle. So once again, center is the order pair 2, -1. Radius is 3. I'm going to write the opposite of what we see in our factors for the center of the circle. So we're going to have x minus 2 quantity squared plus y plus 1 quantity squared is equal to the radius, which is 3 squared, or 9. That would be the center radius form for this graph of this circle, which is given to us. Any questions on this? All right, so they give us the graph of the circle. What we want to look for, the center of the order pair that represents the center of this circle given, as well as the units or the distance for the radius, which is the center of the circle to any end point. And if we look from here to here, still 3 units, from here to here, still 3 units, all from here to here, still 3 units. All right. Now, the last type of problem that we're going to see, where we have to find the center and radius, but we're not given a graph, or we're not given the circle center or the radius itself. So if we have to find the center of the radius, Our first step, we're going to group our x's together and our y's together, and then move the constant away. So first, we're going to get our x's together, get our y's together, and move the constant away. And if that doesn't make sense right now, just write it down and make more sense when you see the type the way the problem is presented to us. And this is when we're going to complete the square for both our x's and our y's, making sure that we balance out our equation. So this is a reminder. When we're completing the square for our x's, we want to take the coefficient with x in it, divided by 2, and square it. And we're going to do the same thing for our y's. We're going to take the coefficient with y, divide it by 2, and square it. Remember in chapter 1, when we completed our squares, this is how we found that number that makes it a perfect square trinomial. Keeping in mind that whatever we add to one side, we need to add to the other side. And that's actually step 3. Add that magical number that we use to completing the square with to both sides of the equation. This way, we're not changing the value of anything, we're simply changing the way the problem looks. Remember, that's the whole point. We want to take it from the way it's presented to us and put it in that center radius form. All right. So an example of this, if we're given the equation x squared plus 4x plus y squared minus 8y minus 44 is equal to 0. And we're told that this is the equation of a circle, and we need to find the center and the radius of the circle. All right, so our first step, like it says, we want to group our x's together, move our y's together, and move our constant away. So what I would do, add 44 to both sides. I'm going to leave space for that number that I know I'm going to have to add to make these perfect square trinomials. So my x's are already together, my y's are already together. I'm just going to rewrite this as x squared plus 4x plus something plus y squared minus 8y plus something is equal to 44 plus those same two somethings. I kind of ran out of space there. All right, so whatever we add here and here, we need to add again on the other side of the equation to keep it balanced. Now, the way we're going to find that number is by completing the square, by taking half of the x term and or the y term and squaring it. That's what's going to give us that perfect square, or that number is going to make this a perfect square trinomial. So for the x's, just focusing on the x's right now. The coefficient for the x term, 4. So we're going to take 4 divided by 2 and square it. We know half of 4 is 2. 2 squared is 4. So we're going to have to add 4 here to make it a perfect square trinomial. And if we do it to one side, we need to do it to the other as well. I'm going to do the same thing for our y's. The coefficient for our y term was actually -8. So we're going to take half of -8 and square it. You know, -8 divided by 2, -4. -4 squared gives me 16. So I'm going to have to add 16 here to make this a perfect square trinomial. And if I did it on this side of the equation, I'm going to need to do it on the other side as well. I ran out of space here, so that 16 should be right over there. Now, the whole point of us completing the squares to make it a perfect square trinomial. Remember, that if it's a perfect square trinomial, then we can just factor these two trinomials here. So we're looking for two numbers we can multiply to give me +4 that I can combine to get positive 4 as well. That number is positive 2 and positive 2. Remember, this is always going to be a perfect square trinomial. So it's always going to be x plus some number squared or x minus some number squared. In this case, it's going to be x plus 2 squared plus, we'll do the same thing, factoring y squared minus 8y plus 16. Two numbers we can combine to get 16. So two numbers we can multiply to get positive 16. And we can combine to get negative 8. Those numbers are negative 4 and negative 4. Remember, we did this, so those factors are exactly the same, making a perfect square trinomial. So it's going to be y minus 4 quantity squared. And it's going to be equal to 44 plus 4 plus 16, or 64. Now, in terms of the center and the radius, remember our center, it's going to be the order pair HK. Remember, keeping in mind it's the opposite of what we see. So my center would be negative 2, positive 4. For my radius, it would be the square root of the number that we see in our equation. So the square root of 64, 8. Right. Any questions on this? So if you had a struggle with completing the square, there's another opportunity to get this under our belt. Let's do another example of one just like this. Make sure I'm not going too fast. Anybody still copying from up there? Same type of problem. This time, we're given the equation x squared plus y squared minus 6x plus 10y is equal to 1. All right, so our first step, we want to organize it so our x's and our y's are together. So I'm going to rewrite this as x squared minus 6x plus something plus y squared plus 10y plus something is equal to 1 plus those same two somethings. Remember, whatever we do to one side, we do to the other. We want to keep the equation balanced. We're not changing the values of x or y, we're simply changing the way that it looks. So to get that number that's going to make these x terms a perfect square trinomial, we're going to take half of our x term, in this case, negative 6, and divide it by 2. Take half of negative 6 and square it. So it's going to be negative 6 divided by 2, quantity squared. We know negative 6 divided by 2 gives me negative 3. And negative 3 squared gives me a positive 9. So we're going to have to add 9 here, as well as add 9 over with our constant term to keep the equation balanced. And do the same thing with our y term. The coefficient in front of our y is 10, so we're going to take half of 10. Our 10 divided by 2 quantity squared. That's going to give me 5 squared, because we know 10 divided by 2 is 5. Or we're going to have to add 25 to make it a perfect square trinomial. And if we do it to one side of the equation, I'll do it to the other side as well to keep the equation balanced. All right, now, once we've completed the square a few times, we'll notice that when we factor it completely, it's always going to be x plus some number or minus some number squared plus some y plus some number minus some number squared is equal to a constant, typically a perfect square, but not always. To get the x term, notice that when we had that negative 6 divided by 2 squared, the number that we need that we can multiply, or the numbers that we need to multiply to give me positive 9 that we can combine to get negative 6, it's always going to be that number that we got right before we squared it when completing the square. All right, now if you remember that, that could save you some time. If not, you can still just factor it. You're going to get the same answer. All right, so negative 3 times negative 3 gives me positive 9. Negative 3 minus 3, or negative 3 plus negative 3 gives me negative 6. So the factor for y would just be y plus 5. If we notice that pattern, quantity squared. And of course, 1 plus 9 plus 25 is going to give me 35 for my constant. So in terms of the center, the center is the opposite of what we see, or in this case, 3, -5 is the ordered pair representing my center. And my radius is actually the square root of 35. Remember, we always take the square root of the number that we see in the equation. So if it's a perfect square, most cases it'll work out fine, but in this case, 35 isn't a perfect square. So the radius is just a square root of 35. Are there any questions on this example?
You said the center is always the opposite of what we see.
In the equation, yes. Any other questions though? All right, so these are the only type of problems that we're gonna see for 2.1 and 2.2. The homework is already attached on Blackboard. Remember, I'm gonna be in the office tomorrow from 1 to 3, so if you have any questions, that's a good time to come by. If you don't have any other questions, that's all we have for today, and I'll see you guys on Wednesday. Oh, remember, check Blackboard. I will be putting your test results up today.